You're watching a Channel 98 NBISD TV production.
Hi, welcome to the basement of New Braunfels ISD headquarters where we film this show being That Geometry Show. I'm your host, Kevin Corpy, and today we're going to talk about in Lesson 2, measuring segments and congruences. We're going to be finding midpoints and other good stuff. So remember that everything I'm going to be doing today, I'm going to have a handout that's available online at the district website, www.newbraunfels.txed.net. So it's not only for you students out there to download, but parents as well can log onto a computer, download them, and work along with me at home. It's a good opportunity for you not only to learn geometry, but to maybe get an idea of what your kid's doing in class, and maybe even, if we're lucky, to give them some help too. So we got a lot to do today. Let's just jump right on in. All right, Lesson 2 corresponds with the Glencoe geometry textbooks you have, chapters 1.4 and 1.5. Today we're dealing with segment measurement, midpoints, and congruence. So last time we looked at points, lies, and planes. Today we're going to go further, and we're going to investigate points on a line and the segments between the 2 points. So by the end of the show, you should be able to, number 1, find the distance between 2 points on a number line and between 2 points in a coordinate or a Cartesian plane. Number 2, you should be able to use the Pythagorean, that's a good word there, the Pythagorean theorem to find the length of the hypotenuse of a right triangle. And number 3, you should be able to find the midpoint of a segment. Okay, and you're lucky because today we'll even get a chance to use some good old algebra that you learned last year. Okay, now let's review a little bit from last episode. Remember that a line segment is a piece of a line that consists of 2 endpoints and all the points in between them. It's denoted by the capital letters of the 2 endpoints with a line above them, such as AB with a line. That means segment AB. The length, remember, of the segment matters. Now, a word about length here. We're going to be using some words interchangeably. When I talk about length of a segment, that's the same thing as the measure of the segment, which is also the same as the distance between the 2 points. In this case, A and B. So length is the measure, is the distance between the 2 points. Now, there are 2 ways to measure the lengths of the segments, with a ruler, or we can calculate them using the number lines. Now, since I didn't bring my ruler with me today, and unless you have one sitting there, we're going to go with the calculations. Okay? First, we need to look at some definitions. The first one is the number that corresponds to a point on a number line is called the coordinate. The coordinate of the point. For instance, if you look at this number line down here, I can put a dot or a point at the point 3 and call it A. So we'd say on this number line, which is only 2 dimensionals, the coordinate of point A is 3. Got it? All right, now, the number of units from 0 to any point on the number line is called its, 2 words here, absolute value. Okay? Now we always use the double barred symbol to denote this. By the way, the absolute value is always, not sometimes, not on Sundays, just on Sundays, but always. Okay? It's always positive. Now, we can think of the absolute value not only as a distance, but also when it's written with these double bars, it could be kind of an operation. So let's look at some examples using the absolute value before we start putting it to use. We read this as the absolute value of 5. So basically all we do is we take the number in the absolute value bars and make it positive. Well, 5 is already positive, so the absolute value of 5 is 5. The next one, the absolute value of negative 5. Well, we're interested in how far negative 5 is from 0 on the number line. It's 5 units away, so the absolute value of negative 5 is positive 5. Look at the next one. Ooh, 2 plus 5. You could think of the absolute value signs kind of like parentheses when you're doing your order of operations. Everyone knows their dear Aunt Sally and how we need to please excuse her. Well, the please is the first thing we do. It's parentheses. And you could think of the absolute value signs as being parentheses. So let's do what's inside first. So the absolute value of 2 plus 5 is the absolute value of 7. And we just make that positive. It already is. So 7 is the answer. Now look at the next one. Absolute value of 2 minus 5. We do the operations first. That's the absolute value of what kind of 3? Negative 3. And the absolute value of negative 3 is, of course, positive 3. You get the idea? We're now ready to find the distance between 2 points on the number line below, namely points A and B. Now finding this length, like I said, is the same as finding the length of segment AB. And again, we notate the segment with the line over AB. And we denote the measure by writing just the letters, the capital letters AB without a bar above it. And I know firsthand that some of you students out there are having a real difficult time designating between AB with the bar above and AB without the bar. Without the bar, again, it means we're talking about the measure of the segment, the length of the segment, or the distance between the 2 points A and B. Let's look at this example. I've got these 2 points here on the number line. Point A has a coordinate of negative 4. Point B has a coordinate of 2. Now, how can we figure out the length between A and B? Well, we can figure it out by counting. That's one way. We all know how to count. We can count the number of units in between them, or, again, we can calculate it by subtracting the 2 coordinates. Well, let's do it by counting first. This is not a very big number line. A and B are not that far apart. So let's count. From A to B, it's 1, 2, 3, 4, 5, 6 units. So we could say down here that AB without the bar, meaning the measure of AB, is 6. Now that's fine and dandy, but what if those 2 points were not 6 units away? What if they were 100 units away or 1,000 units away? Do we really want to sit there and count 1,000 little points on the number line? The answer is not if we have a life, okay? We want to figure out a better way to do it. And the better way to do it is by using math, algorithms, by subtracting the coordinates. This works every time. Let me show you what I mean. The length of AB is, I take the first coordinate, negative 4, and I always subtract the other, minus 2. Now we're looking for the distance between them, so we want the distance to always be positive. How do we do that? You guessed it, we take the absolute values. So if we always take the absolute value of the difference between the 2 coordinates, we'll always have the distance. Let's try it out. Negative 4 minus 2, you owe me 4, you owe me 2, you're going to owe me 6. All right, now the absolute value of negative 6 is, of course, 6. We get the same answer. Now let me show you that it doesn't matter which coordinate we start with. Over here we started with the coordinate of A. What if I'm just a B type of person and I want to start with B? Well, the coordinate of B is 2, and now let's subtract A. Minus, always subtract. A happens to be a negative number, so we're actually subtracting a negative 4, and then we put the absolute values. Now, subtracting a negative is really the same as adding, so that becomes the same as the absolute value of 2 plus 4, which is the absolute value of 6, and as I run out of room here, we get the final answer is 6. We get the same answer both ways. So it doesn't matter which coordinate you start with, so long as you remember to subtract the 2 and take the absolute value of your answer. All right, also notice that above, we can say the measure of AB is the same as the measure of BA, since they represent the exact same segment. But what if another segment that was different, a unique segment, had the same length? Well, I'm glad that you asked if you did. It's time for another definition. Here we go. 2 segments are considered to be congruent. That's a good word. Congruent, if and only if they have the same length. We use the symbol that looks like an equal sign with a little tilde above it. Okay? Now, for instance, I want to show you on this segment below, that segment's AB, and it's the same segment we talked about, the segment from negative 4 to 2, and CD, segment CD, are congruent. Now, notice CD is notated here in red. So if I look at segment CD, it's in a different location on the number line, so it's not just renaming segment AB or BA. It's a different segment. Let's see what the length of CD is. CD, the length without the bar, equals the absolute value of, the first coordinate for C is negative 1, minus, always minus, the coordinate of D in this case, which is 5. So I do what's inside the absolute values first. Negative 1 minus 5 is negative 6, and of course the absolute value of negative 6 is positive 6. So that's the length of CD, which happens to also be the same as DC. That's the same segment. But because AB, the blue segment, and CD, the red segment, have exactly the same length, we can say that AB segment with the bar is congruent to segment CD. And the reason that is because AB length is equal to CD length. Okay, so we say the segments are congruent because their measures are equal. Let's move right along to another example. Here's one right here. We've got a figure here, and we want to determine which of these segments on this little fancy shape here that you might see in your textbook, which of these segments are congruent. Okay, well, let's look to see what we have here. We have segment MN, we have segment NR, and we have segment MR. We have PN, PQ, and RQ. So we have all those segments, and these little numbers here, I'm going to have to zoom in for you to see it. They represent the lengths of the segments. Okay? Now we want to be careful. If those lengths were not there, sometimes a graph could be misleading. If there was no measurements of lengths, it'd be hard to tell which ones were congruent. They could be close, but it's hard to verify if they're actually the same length. So we need the numbers in this case. Well, let's look to see what the longest length is. The longest length here is 10. Okay? Do we have another segment that's 10? Well, not really. Okay, we have this one is 9. We have this one is 10. Much better. We have this one is 4. This one is 6. Okay, this one here is 8. So none of them are 10. Well, let's see if we can actually get one of the other numbers by adding 2 together. You might notice right away here that this length appears to be the same length as PQ. Now, how can I figure out what segment MR is if I know that segment MN is 6 and segment NR is 4? Well, this kind of leads us to a very, very important postulate, which is kind of like a no-duh statement. Thank you, Ms. Karadek. Here's what the postulate says. It's the segment addition postulate. And basically it says that if you have segment MN and segment NR comprising segment MR, then the measure of MN plus the measure of NR has to equal the measure of MR. Okay? Duh, right? So here we go. MN is 6 units long, NR is 4 units long, and therefore we know MR is 10 units long. And MR is the same length as segment's PQ length. PQ, there's a G, there's a Q. Okay, so basically let's see. If we know then that segment PQ is congruent to segment MR, which choice is that? Well, it happens to be the first one down here. Segment PQ and MR are congruent because their lengths are equal. Okay, now it's time to take a break and look at some public service announcements, and we'll be right back, so don't go anywhere.
Bad people, the gang members in the neighborhood. My brother, he wouldn't be happy at all if I was to tell him I was going to drop out of school. He would not approve of that, because then that's going to be 2 of us not handling our business.
Me and my friends are close, and we all believe in each other. I know they could graduate, even if it takes them longer than the 4 years.
We have classes together, so
we study together, we help each other with our homework.
Realized we messed up in the past.
Failed a couple classes before, not doing as much work as I should be doing. My 2 best friends, they keep me working hard.
He's fearless, focused, and 100% hypoallergenic. Send someone's teddy bear to Congress on November 7th. This message paid for by Citizens for Someone's Teddy Bear.
If you're not voting, then who are you electing?
Let's jump right back into Lesson 2. Another example dealing with segments here. If segment FG is congruent to segment UV, and segment UV is congruent to segment PQ, then what the heck we got here? We have to figure out which other 2 segments are congruent. Well, let's think about the segment addition postulate. Will that help us? I've got a segment FG that's equal to UV. I also know segment UV, ooh, there he is again, is congruent to another segment PQ. Well, how about this? If FG is equal to UV and UV is equal to PQ, then since FG and PQ are both equal to UV, doesn't it make sense that they should be equal to each other? Absolutely. And if their lengths are equal, then we can say that segment FG and segment PQ are congruent. And that is choice A. Okay? Now, let's try this. It involves thinking, and it definitely involves some algebra. It's going to be helpful to make a drawing, which I've already done. Find the length of DF if D is between E and F. Read that again. D is between E and F. Now, if you don't have the drawing, you can draw at point E and point F and draw point D anywhere in between them. Where it is does not matter. I decided to put it right here. Now we have something that we can label. It tells us that the measure of ED, which is this here now, is 6x minus 4. Well, that's not a number. Well, not yet. If we knew what x was, it would be a number. Our goal is to find x. We also know that DF is 3x plus 5, so I've labeled this segment 3x plus 5. Again, it's not a number unless I know what x is. Well, look what else they tell us. EF, the length is 46. So this whole length here is 46 units long. So we can use the segment addition postulate to help us find the length of DF, which is what this is. So here we go. We know that ED, the length, plus DF, the length, has to equal the length of EF. Now let's plug in what we know. The length of ED is 6x minus 4. Put it in parentheses to denote that it's this quantity. Plus DF is 3x plus 5. And that should equal EF, which is 46. So I've basically taken the information, written it out, and now written it in terms of my given information in terms of x. Well, now I can collect like terms from algebra. So I get 6x plus 3x, which is going to be 9x. I'm going to have a negative 4 plus 5, which is really 5 minus 4. That's plus 1 equals 46. Now all I have to do is get my 9x by itself by subtracting 1, and I get 9x equals 45. Dividing both sides by 9 gives me a value of x that is 5. Now a lot of us feel pretty heroic and pretty happy that we found x. So we might be tempted to move on to the next question, but it's always important that we answer the question. We're trying to find the length of DF. DF, remember, the length is 3x plus 5. So now I have to take my x and plug it back in here. So DF is equal to 3 times 5 plus 5, which is 15 plus 5, which always has been 20. So again, answer the question. Very important. Okay, now we're going to step it up a little bit here, a dimension actually, and we're going to find the distance between 2 points on a coordinate plane. To do this, we must use the Pythagorean theorem. Okay, now what's a theorem? I'm glad you might have asked. A theorem is a statement that can be justified using logical reasoning or proven using other theorems or axioms. Basically, it's like a law or a true statement. Now, the Pythagorean theorem is one of the breakthrough theorems in all of mathematics. We'll talk about that later on in another episode. But basically, it says the sum of the square of two legs of a right triangle, leg 1, leg 2, equals the square of the hypotenuse. Here's a diagram, 2 legs, and the hypotenuse is the longest side opposite the right angle, always. So we could basically say leg A squared plus leg B squared equals the other side squared. And it doesn't really matter which one we're calling A and B, they're just the 2 shorter legs. Now here's how it works. If one leg of a right triangle is 17.2 centimeters and the other leg is 22.5 centimeters, what's the length of the hypotenuse, the longest side? So it doesn't matter which one we're calling A and B. Let's just set up the equation. A squared plus B squared equals C squared, where C is the hypotenuse. So I'm going to get 17.2 squared plus 22.5 squared, and that's going to equal C squared. Well, this is where a calculator comes in very, very handy. I've already done the work, so I know that this is going to turn out to be 295.84 plus 506.25, and that's going to equal C squared. Working down here, I get C squared is equal to 802.09. And how do I solve for C? Well, I have to undo squaring it, and I do that by taking the square root. Now, usually when you take the square root, you're taught to take plus or minus. But in this case, because we're talking about a length of a triangle, we do not want to talk about a negative length, so we take the positive version. So there you go. So we know right away that the other side is approximately 28.321, and I better put my units. Centimeters, because that's what was given. Okay, now it's going to get a little more interesting. The formula to determine the distance d between 2 coordinates, x sub 1, y sub 1, that's just one coordinate on the coordinate plane, and x sub 2, y sub 2, is given by this monstrous formula. It's the distance formula, and it's something you have to memorize. There might be a way to help you memorize a little bit easier. X sub 2 minus x sub 1 is just the change in the two x values. So we can denote the change in the x values as delta x, and the change in the two y values as delta y. And it's d equals the square root of then delta x squared plus delta y squared. Now this is nothing more than the Pythagorean theorem on the coordinate plane. Let me show you where this comes from very quickly. If I have any two points, x1, y1, and another point up here, draw it anywhere, x sub 2, y sub 2, then I'm looking for this, the distance between them, little d. If I drop a perpendicular straight down and come straight across on the coordinate plane, I've made a little right triangle. This distance here is going to be the change in my two x values. That's x sub 2 minus x sub 1, or delta x. This distance here is the change in the y values, y2 minus y1, or delta y. So, by the Pythagorean theorem, where d is the hypotenuse, I get delta x squared plus delta y squared equals d squared. And if I solve for d by taking the square root and conveniently flipping the equation, I get delta x squared plus delta y squared. So it looks pretty intimidating with all these little subscripts and exponents, but it's nothing more than the Pythagorean theorem on the coordinate plane. Okay? Now that we have that, let's put it to good use. Let's go ahead and find the length of segment JK in this figure at the right. Now for this, we're going to use the distance formula. Let's identify. There's J, there's K. We know the point JK is at negative 5, 3, and point K is at the point 1, 2. So let's go ahead and write our formula. The distance is the change in the x values. So the first one is negative 5. And what's the next one? Minus 1. So change in means subtraction. And then I square that. Plus the change in the y values. Negative 3 minus 2 squared. And now all I have to do is evaluate this under the radical and work my way out. So this is the square root of negative 6 squared plus negative 5 squared. And anytime we square a negative number, we get a positive number. That's why these parentheses here are very important. Negative 6 squared is negative 6 times negative 6, which is the positive variety of 36. And negative 5 squared is 25. Adding those two together, we get the square root of 61, which without a calculator is approximately between which two values? What did you say? Yeah, 7 and 8. Okay, because 7 squared is 49 and 8 squared is 64. Now, if you had a calculator, your teacher's nice to let you use one, it's approximately 7.810 units. And we don't have any centimeters or anything measured there, so it's just 7.810 units. Okay, now notice that the order in which we subtract does not matter, because squaring kind of has the same effect that absolute value does. We're going to make the numbers positive, and by building them up by squaring them, we come right back and take the square root, so we kind of get them back where we need to be. The order in which we subtract does not matter. Let's look at another example where we're flying by instrumentation only. We don't have the graph. Find RT without the bar. Remember, that's the length RT if R is this point and T is that point. Okay? We'll just go ahead and use the formula. So the distance, or the length of RT, same thing, is the square root of the change in the x's, negative 2 minus negative 3. This is where some students get caught up. We're always subtracting. We're subtracting a negative squared plus the change in the y's, 5 minus negative 6 squared. So now I'm working from the inside out. Negative 2 minus negative 3 is negative 2 plus 3, which is 3 minus 2, or 1 squared, plus 5 minus negative 6 is 11 squared. So I get the square root of 1 plus the square root, or 11 squared is 121. I get the square root of 122, which is between 11 and 12, really close to 11. Again, with a calculator, it's approximately 11.045. So if you look at our answer choices, there he is. Now notice we could have answered this question without a calculator. Don't get mad at your teacher if she gives you one like this on a test and she doesn't let you use your calculator, because you should be thinking that the square root of 122 is going to be between 11 and 12. Okay, because 11 squared is 121, which is smaller than 122, and 12 squared is 144, and the only choice that's between 11 and 12 is 11.0. Okay, so we can do that without a calculator, but it's nice to kind of know exactly what it is here. Okay, now we're going to look at finding midpoints of segments. And just as before, we can look at the number line or on the coordinate plane. And of course, some definitions are required before we continue. A midpoint is the point between a segment that divides a segment into two equal segments. The midpoint is then said to bisect the segment. Now the midpoint C in this diagram below bisects segment AB if and only if AC is congruent to segment CB. And sometimes if two segments are congruent, we'll put a little hash mark on them or a tick mark on them to show that these two segments are equal. And if they're equal, then C is the midpoint, and C again is said to bisect the segment. Now on a number line, it's pretty easy. The coordinate of the midpoint of a segment on a number line whose endpoints have coordinates of A and B is just A plus B, add them together and divide by 2. It's the average of the coordinates. All right, I'll show you what I mean. It's not too bad. Let's find the midpoint of segment XY on the number line shown below. Well, let's first identify segment XY. It goes from here to here. Now, some of you might be tempted, because it's short distance, to find the midpoint by counting 1, 2, 3, 4, 5, 6, 7 units in between them. Half of 7 is 3.5. So if we work our way 3.5 from the left, 1, 2, 3.5, and 1, 2, 3.5 from the right, we're at the same place. That's halfway between 0 and -1, which is -1/2 or -0.5. Okay? Now again, what if the segment was a much larger distance? We wouldn't want to do that. So we can find it by calculating using the formula A plus B for any two coordinates divided by 2. So in this case, we're looking at x plus y divided by 2, and the coordinate of x is 3, plus the coordinate of y is -4 divided by 2. Well, 3 plus a -4 is the same as 3 minus 4, and that's -1 over 2. And we're done. -1/2 is what we got up here. Now, the problems do get more challenging when we're on the coordinate plane because we're stepping up a dimension. In this case, the coordinates of the midpoint of a segment whose endpoints have coordinates x1, y1, and x2, y2 is this. I'll let you look at that. Be in awe of it. It looks pretty intimidating. But notice, we're just doing what we did above twice. A coordinate plane has two coordinates, an x and a y. So we're finding the average of the x coordinates and the average of the y coordinates, and those two averages are a new point. Just like up here, we found the average of a single coordinate. So it's really not that bad. We just have to do it twice. So let's look down here. Let's find the coordinates of the midpoint of segment PQ. Now again, we can't really count this time because the line is at an angle. So we're not going to be able to count and get the actual number here. So we're going to have to do this one by calculating. Well, at first, it helps to write what point P is. Point P is -4, 2, and point Q is at 2, -3. We did that last time. So now, the midpoint is going to have coordinates. Well, I just take my two x coordinates, -4 and 2, and add them together. -4 plus 2, divide by 2, taking their average. And I take my two y coordinates, 2 and -3, 2 plus a -3, and divide by 2. And then all I have to do is simplify each of the coordinates. -4 plus 2 is -2 over 2, and 2 plus a -3 is -1 over 2. And of course, 2 over 2 then goes a little bit further, and we can write that as -1, -1/2. That's answer A, but it always helps to come back and make sure that our answer is reasonable. -1 is left from the origin 1 unit, and down 1/2 is right there, which does fortunately land on the line, and then you can kind of eyeball, and it does look like P and Q to the midpoint are the same length. So that's a good verification that we did it correctly. Now here's one a little bit trickier. What are the coordinates of L if K happens to be the midpoint of JL? Well, here's J, here's L, and this time we know the midpoint. The midpoint is the coordinate 1, 2, and we know one of the endpoints. We're trying to find the other one. Well, it helps to label the unknown point. In this case, we'll just call it x and y. Now, the word midpoint is a clue to use the midpoint formula. Let's go ahead and write what we know from the midpoint formula. J is the endpoint and L is the endpoint. So if I add the x coordinates together, -5 plus x, the unknown, and divide it by 2, that's going to be my new midpoint x coordinate. And I take the y coordinates, -3 plus y, and divide by 2. That's my new y coordinate. Well, it just so happens that I know what those two guys are supposed to equal. That's supposed to equal my midpoint, which is the point 1, 2. So we can now set each of these coordinates equal to what they have to be. So I can get -5 plus x divided by 2 is 1, and I also know that -3 plus y over 2 has to equal the y-coordinate too. And so now I have two problems where previously I had one, twice the fun. How about that? Let's solve this equation here. We'll multiply both sides by 2 first. This is where the algebra comes in. 2's divide out, so negative 5 plus x equals 2. And I'll bring the 5 across, and he becomes positive, so I get x equals 7. Now, if you're taking a test, this is a good strategy. Look at your answer choices. If you're confident that x equals 7 is the right answer for your x-coordinate, look at your answer choices. Only one of them has an x-coordinate of 7. So he is probably going to be the right answer, assuming you got this correct. But I'm not going to be able to sleep at night if I don't verify that over here. And I have time. So let's do the same thing. We'll multiply by 2. 2 times 2 is 4. And let's bring the 3 across. 4 plus 3 is 7. So yes, we did verify it. Now the midpoint is the 0.12 and xy is 7, 7. We did it. We did it. And finally, one last interesting example, where interesting is a very relative term. Okay. Find the value of x if Q bisects segment PR. Now bisects means that Q is the midpoint. Now notice we don't have the total length of segment PR like we did previously. We don't need it because by the theorem that says that a midpoint bisects it if and only if the lengths are equal, I can say that the length of PQ has to equal the length of QR. And now plugging in what I know, 3x minus 2 equals 5x plus 6. We have another algebraic equation. We'll group our x's on one side. I always like to get them on the left. So that's 3x minus 5x. And the 6 stays over here, and he invites the negative 2 to come to his side where he becomes positive. So 3x minus 5x is negative 2x's. 6 plus 2 is 8. Then we divide by negative 2. X equals negative 4. You gotta love the algebra here. Now, did we answer the question? We could plug it in to find the length of each segment, but in this case, the instruction said to stop when we found the value of x. So there he is. Okay? Now, it's time for our segment known as Say What? There it is. This is where we kind of do some clarification. Now, I've been talking to a lot of geometry teachers, and it seems like there's some confusion, and it's rightfully so, over the different notations, whether we put a bar or a line or nothing above the segments and what exactly they mean. So I made a little matching game here. There are lots of different notations for lines, segments, and rays. What we need to do here now is correctly match up the notation with what it represents on the right-hand side. So in the first one here, this is AB with a one-sided arrow. I'll write it a little bit larger. It's a one-sided arrow. Well, if you remember from last time, the starting point then is A, and it's fixed, and we go to infinity in the other direction. That has to be like a beam of sunshine, a sun ray, okay? Ray AB. Now this one here is AB with a double-headed arrow over it. That means it goes on to infinity in both directions. That's straight across. That's a line. AB with just a bar over it with no arrows means that the length matters. You can imagine putting 2 points there, but it's just a bar, and that's segment AB. And I bet y'all can figure out the last one by process of elimination. This is very important. If you see AB with nothing above it, don't just assume that the teacher forgot to put something there, although that might be a possibility. If the context of the problem is asking for a length or a measure or a distance between AB, and that's what you see, that's exactly what it is. Okay? You need to have all this notation clarified before you can proceed and be successful. Because if you don't know what's being asked, you don't know how to find what's being asked. Now, that concludes today's lessons. Now, if you're like me and lucky, you probably burned a few calories during today's lesson. It was pretty intense. There was a lot of new terminology, and we clarified some things there at the end that are very important that you get down before you proceed with your homework. Remember, if you don't have the terminology or the definitions down, you really don't have much of a chance of being successful with the calculations. Now, come back next week where I'll give you the angle on how to learn about angles. And we'll see you then. Till then, I'll catch you on the flip side.
You're watching a Channel 98 NBISD TV production.